All the organic chemistry content you need to know for paper 2, AQA GCSE Chemistry Exam in 10 minutes. So first of all, how to represent organic molecules. The general formula is the type of empirical formula that represents the composition of any member of an entire class of compounds, basically homologous series. For example, for alkenes, it's CnH2n. And then there is the molecular formula, which gives you the actual number of each element in the compound. Homologous series are these compounds which have the same general formula and the same functional group. You can use the general formula to work out the molecular formula. Each member differ by only CH2 in their molecular formula from the neighboring compounds, and they show gradual variation in the physical properties such as their boiling points, but they have similar chemical properties because they have a similar functional group. So the hydrocarbons are these organic molecules which only have hydrogen and carbon in their structure. So we have the saturated hydrocarbon represented by alkanes. They are saturated because they don't have any double bond. And then we have the unsaturated hydrocarbons represented by alkenes because they have this double bond, so they are called unsaturated. To compare between these two, first of all, let's start off by naming alkane and alkenes. First, you need to know the prefix in the name. So the prefix refers to the number of carbon atoms in the chain. So if it's one carbon atom, it's meth, two, it's eth, three, it's prop, and four is but. And then we have the suffix which is the second part of the name. In case of alkanes, it's ane, and in case of alkene, it's ene. So for alkanes, it's going to be methane, ethane, propane, butane. And for alkenes, of course, we're going to start with ethene, propene, and butene. There is no methane because you have to have two carbon atoms. The smallest alkene must have a minimum of two carbon atoms. The general formula for alkanes is CnH2n plus 2. For alkene, it's CnH2n. So for their properties, chemical reactions, first of all, boiling points and viscosity, both alkanes and alkenes, the increase in the number of carbon atom in the chain will lead to an increase in the boiling point and also increase in the viscosity. This is because of the increase in the intermolecular forces of attraction between the molecules. So we will need higher temperature in order to break these bonds. Both of them can undergo complete combustion. Complete combustion, this is in presence of excess oxygen, will give you carbon dioxide and water. Incomplete combustion, when there isn't enough oxygen, that will give you carbon monoxide, sometimes also give you carbon particulate. Flammability will decrease with the increase in the carbon atoms in the chain. Addition reactions, so this is the type of reaction which we only see in alkenes but not in alkanes. Alkanes are not very reactive in comparison to alkenes. Alkenes are more reactive than alkenes because they have this double bond. And this double bond allows for a type of reaction called addition reaction, where a small molecule is added to the double bond to make a new molecule. So when you add chlorine, that will give you dichloroalkene. So basically the double bond is broken and then you replace it with 2-chloride. And then if you add water, that will give you an alcohol where the hydrogen is added to one carbon and an OH is added to the other one. And if you add bromine, that will give you dibromo alkane. And then if you have a hydrogen, that will give you alkanes. The test that we use to distinguish between alkane and alkenes is the bromine water test. This is the test for double bond. So with alkane, there will be no change. The orange color of the bromine water will stay. But in case of alkene, because of the addition reaction, bromine water color will change from orange to colorless. We get the alkanes from the fractional distillation of crude oil, which is a mixture of different hydrocarbons with different lengths. So how to separate the crude oils into fraction? First of all, you heat the crude oil in a furnace, and then the vapors will rise up in a fractionating column where there is a temperature gradient inside the column with higher temperature at the bottom and lower temperature temperatures at the top. And then the different fractions will condense and will be collected at different points from the fractionating column, where the increase in the boiling, the higher the boiling point of the fraction, the lower it will be collected from the fractionating column. As you go down, you can see that the boiling points and viscosity will increase. Cracking is very important because most of the fractions we obtain from the fractional distillation are long chain hydrocarbons, which are much less useful than the shorter chain. Sure, there is a high demand for shorter chain hydrocarbons because they are used as fuel. Also, the process of cracking will give you, in addition to a shorter chain hydrocarbon, will give you also an alkene. And alkenes can be used to make polymers. So the conditions for cracking, you would need high temperature, and then you need to use either a catalyst or you need to use steam. So for a catalyst, this is for catalytic cracking, steam in case of steam cracking. The products of cracking will be shorter chain alkanes and unsaturated hydrocarbons, which are an alkene. Alcohols is another series of one of the homology series. They have the OH functional group. To name an alcohol, you just remove the letter E from the name of the alkane and replace it with ol. So you have methanol, ethanol, propanol, and butanol. Ethanol can be used as fuel because it can undergo complete combustion to give carbon dioxide, water, and heat. Ethanol can be formed from ethene by addition of water, as we have seen in the reaction before reactions of alkenes. However, in industry, they usually tend to make ethanol from fermentation of glucose using yeast. So the equation is that glucose will give you carbon dioxide and ethanol. Because yeast is used here to provide the enzyme that is needed for this reaction will have some optimum conditions. So the optimum temperature here is 25 to 35 degrees. If we use lower temperature, the enzyme will become inactive. Higher temperature, that will lead to denature of the enzyme. So also it needs to be done in the absence of oxygen because oxygen will oxidize the ethanol to give the carboxylic acid called ethanoic acid. So you need to do this in the absence of oxygen. Carboxylic acids have this functional group, which is the carboxylic acid group, which is C double bond O and then an OH. This is the functional group for a carboxylic acid. To name carboxylic acid, you remove the E from the alkane name and replace it with oic acid. For example, methanoic acid, ethanoic acid. This is ethanoic acid here. They are formed by oxidation of alcohols, as we have said. Carboxylic acids are weak acids, but they are still acids and they have the typical acid properties. So they dissolve in water to produce acidic solution with pH less than 7. They react with bases like metal oxides and metal hydroxide to give salt and water. They react with metal carbonate to give salt, water, and carbon dioxide. The salt here is the salt of the acid. So if we react sodium carbonate with ethanoic acid, the salt would be sodium ethanoate. And they also react with metals to give salt and hydrogen. So if they react with sodium, for example, that will give you sodium ethanoate and hydrogen gas. Esters have the COO functional group. They are formed from a reaction between carboxylic acid and alcohol by removal of water molecules. So you have ethanol here as the alcohol and ethanoic acid as the carboxylic acid. A water molecule is removed with an OH is taken out from the acid and a hydrogen from the alcohol to make the ester functional group, which is the COO, in addition to the water molecule. In order to name the ester, it has two parts. The first part is going to be taken from the alcohol. So you start with alcohol, remove anol from the name of the alcohol, replace it with yle. So this is ethanol, remove anol and replace it with yle. So it's going to be ethyl. The second part comes from the carboxylic acid by removing oic acid, replacing it with O8. So this is ethanoic acid. So the carboxylic acid will be ethanoate, part will be ethanoate. So this is ethyl ethanoate. Polymers. We have two types of polymers. We have addition polymers and condensation polymers. Addition polymers are formed by joining up small molecules of the same type, which are alkenes, and only one product are formed here. To draw the polymer from an alkene, all what you need to do is to remove the double bond and replace it with a single bond, and then add two other single bonds to the two carbons, and then open brackets and put the letter N, which refers to the number of the repeating units. Don't worry about the different substituents here on the carbon. Whatever you have, you just need to add it exactly the same on your polymer. So if there is CH3 here, you need to add CH3 here in your polymer. Condensation polymer, on the other hand, they are formed from two different molecules, not the same one. One has a carboxylic acid and one has an OH group, and they form through a condensation reaction. Condensation means a removal of a water molecule. So through this condensation reaction, we end up with two molecules. One is a large one, which is the polymer, condensation polymer, where an ester functional group will be created here. And then we have a small molecule in addition, which is the water molecule. This is an example of polyester, which is one of the condensation polymers, where we have the carboxylic acid, dicarboxylic acid compound, and the dialcoholic compound. A condensation reaction takes place here, where the OH and H are removed in the form of a water molecule, and a new ester link is formed. And this is the repeating unit for the polyester. Remember that the carboxylic acid in the carboxylic acid functional group, we only keep the C double bond O, and then for the alcohol, we keep the oxygen and then open the brackets, and this is the repeating units. Naturally occurring polymers, we have proteins. Proteins are formed of a polypeptide chain where there are many amino acid linked together. They form the peptide bond, and the small molecule removed here is also water. And then we have the DNA. DNA is formed of two polymer chains of monomers called nucleotide. What you need to know about the DNA for your chemistry exam is just that these two polypeptide chains are these two polymer chains are linked together through hydrogen bonding between nitrogenous bases, and just you need to know the letters for the bases. You don't need to know